In EVA's case, however, mining plays a central role in the economic model and helps explain how the project structures its backing, transparency, and the long-term growth of the burn vault. EVA's mining operation is neither conceptual nor outsourced through opaque arrangements. It exists in the physical world, with its own infrastructure, dedicated technical teams, and operational processes that can be observed, audited, and verified. In addition, the project integrates operational partnerships with independent miners, expanding productive capacity without sacrificing transparency or control over Bitcoin flows. Currently, the mining operation associated with EVA generates around 15 BTC per month. Of that total, roughly 7 BTC come directly from the project's own mining units, which now operate more than 2,000 ASICs distributed across different facilities in Paraguay. The remaining volume comes from partnerships with external operators who contribute computational power under clear, measurable rules integrated into the project's economic model. As a result of this continuous flow, the burn vault currently holds more than 330 WBTC, a figure that can be verified on-chain at any time. This physical base matters because it connects the on-chain ecosystem to a real, measurable economic activity. The mined bitcoins do not stay off-chain. After mining, BTC is converted into WBTC and sent to the burn vault, a smart contract on the Arbitrum network. All of this flow can be tracked by anyone through public blockchain explorers such as Arbiscan without relying on private reports or team statements. The smart contract responsible for the burn vault has undergone independent audits conducted by Hacken and Certicay, with public reports available for review. This process clarifies a recurring point in the crypto market. This is not cloud mining or a future promise. Mining happens natively. Bitcoin is converted into WBTC, and the backing resides directly in an audited, immutable smart contract that is fully verifiable on-chain. Anyone interested can audit how the contract works, check balances, and track its evolution in real time, without intermediaries. EVA's mining facilities mainly use S21 hydro ASICs, which operate with liquid cooling. This technical choice allows for higher computational density, better thermal control, and greater energy efficiency compared to older models. The plants are organized in a modular way with specific containers for cooling, power distribution, and machine operation. This design supports gradual expansion, preventive maintenance, and equipment replacement without long operational interruptions. Another key point is operational autonomy. EVA's technical team performs diagnostics and repairs on its own ASICs, avoiding long downtime and dependence on international shipping for maintenance. This approach reduces costs, increases efficiency, and contributes to more stable production over time. Transparency is not limited to financial flows. The project's ambassador, Rafael Castaneda, personally visited the facilities in Paraguay, observing plant operations, cooling systems, container activation processes, and the daily routine of operators. This visit resulted in a mini-documentary that captures the operation directly, without staging or excessive filters. In addition, the project announced the implementation of real-time streaming from the mining facilities, allowing anyone to follow activity at the operating units. Guided and educational visits at one of the plants are also planned. A new visit is already scheduled for January, with participation from Latin American influencers. The goal is to expand visibility into operational processes and reinforce the project's transparency proposal. These initiatives help distinguish technical transparency from simple marketing communication. Instead of asking for trust, EVA offers ways to see, follow, and verify. Regardless of infrastructure complexity, the core point of the model remains clear. EVA's WBTC backing resides in the burn vault, a smart contract audited by specialized security firms. This is where mined bitcoins accumulate and begin to influence the minimum redeemable price per token. Since the total EVA supply was fully issued from the start and no new tokens can be created, the economic logic combines continuous BTC inflow with gradual reductions in circulating supply whenever tokens are burned. This dynamic directly links physical mining operations to on-chain economic behavior. In a market where many projects rely on narratives that are hard to verify, EVA's mining operation functions as a structural component of its model. It does not eliminate risk or make the project immune to Bitcoin volatility or global market conditions. Still, it provides a concrete basis for analysis. By making both infrastructure and on-chain data visible, EVA allows anyone to more clearly assess how mining influences backing, liquidity, and ecosystem evolution. For those who follow crypto with a critical eye, this type of approach helps separate purely narrative proposals from models grounded in observable and verifiable processes. If you want to go deeper into analyses of models that connect mining, on-chain transparency, and token economics, follow EVA's channels for more technical and contextual content.